In 9.5, we are going to introduce the binomial theorem. The binomial theorem helps you find the coefficients when you're doing some power of, you're raising a binomial to some power. Okay, but before we do the binomial theorem, you can also use Pascal's triangle to help find the coefficients of an expanded binomial. So Pascal's triangle, at the top of the tree, looks like a tree or a triangle, I guess, is a 1. Okay, on either side, there's also a 1. Okay, now for the next row, there's still a 1 on the edge. Between this 1 and the 1, 1 plus 1 is 2, so I put a 2 here. And then there's a 1 along the edge. For the next row, there's a 1 on the edge. Between the 1 and the 2, 1 plus 2 is 3. Between the 2 and the 1, below it, 2 plus 1 is 3. And there's still a 1 on the edge. Let's do 2 more rows. Okay, so 1 on the edge. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 on the edge. Let's do 1 more row. Okay, 1 on the edge. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then there's a 1 on the edge. Okay, I'm going to show you how these end up being the coefficients when you raise a binomial to some power. So if I look at the first row, we consider this 0. If I do x plus y to the 0, I get 1. 4. Okay, now for the next row, the one that has the 1 and the 1, if I do x plus y to the 1, I get x plus y. And this 1 and this 1 represents the coefficient of the x and the coefficient of the y. Okay, now when I go one more row down, I get x plus y squared. Okay, if I actually multiplied it out, I would get x squared plus xy, so plus 2xy plus y squared. Okay, if I look at Pascal's triangle, the coefficients should be 1, 2, and 1. This is 1, 2, 1. So it doesn't tell you anything about the exponents or the variables, but it does tell you what the coefficients will be. Okay, let me go to x plus y to the third, because I can't do that in my head. Okay, but I do know the coefficients are going to be 1, 3, 3, and 1. Okay, so I'm guessing it's x to the third first. Okay, the next coefficient should be 3. Okay, but what's the variables? The x is going to keep going down. So since the last one was x to the third, that'll still be x to the second. I'm going to give it a y. Okay, Pascal's triangle says 1, 3, 3. The next coefficient should also be 3. The x is going to go down a degree. The y is going to go up a degree. And then the last term, 1, 3, 3, 1. The last coefficient should be a 1. The x goes down a degree, so it's gone. The y goes up a degree. Okay, and that would be the expansion of x plus y to the third. Okay, let's do x plus y to the fourth. Okay, it's going to start with x to the fourth, right here. Okay, the next coefficient is going to be a 4. Okay, the x is going to go down a degree. The y is going to come up a degree. The next coefficient is 6. The x goes down a degree. The y goes up a degree. The next coefficient is 4. The x goes down a degree. The y goes up a degree. 1, 4, 6, 4, 1. Last coefficient is 1. The x goes down a degree, so it's gone. The y goes up a degree, so it ends up with y to the fourth. And if you'll notice, for each of the individual monomials, the degree is 4 every single time because they add up that way. I could keep going x plus y to the fifth, but I shall not. Okay, now we're going to use Pascal's triangle to expand some other binomials where it's not as straightforward as x plus 2 to the third or x plus y to the third. Okay, so let's look at x plus 2 to the third. I don't want to have to do the hard work of actually multiplying it out. So let me see which row this would apply to. This is degree 0, degree 1, degree 2, degree 3. So I'm on this row right here. So 1, 3, 3, 1 is what I'm going for. Okay, I'm going to write it out. Okay, so for the first thing, I'm guessing it's 1x to the third or x to the third. Okay, for the next term, let's see, it's going to have a 3. The x is going to go down a degree. And then the second term, which was y before but is now 2, is going to go up a degree. So now the 2 gets introduced. Okay, 1, 3. Next coefficient should be 3. The x is going to go down a degree. The 2 is going to go up a degree. For the last term, the coefficient should be 1. The x goes down a degree and it's gone. The 2 goes up a degree, so now it's at 2 to the third. I can't leave it like this. I'm going to simplify this. So x to the third, 3 times 2, 6x to the second. 2 squared is 4, 4 times 3 is 12x. 2 to the third is 8. And if I actually multiplied it out, I could confirm that this is the correct expansion of x plus 2 to the third. Okay, let's do one more using Pascal's triangle. Okay, it says it's 2x minus 3 to the fourth. I would not want to have to multiply this out. Okay, I'm raising it to the fourth power, so let me check according to Pascal's triangle what the coefficient should be. Okay, so this is degree 0, 1, 2, 3, 4. Now that's going to have a bunch of stuff. Okay, so it's the row with 1, 4, 6, 4, 1. Okay, so let me write this out. Okay, the first coefficient should be 1. The first, normally I do x to the fourth, but in this case it's 2x to the fourth. The y is not there yet. Okay, the next coefficient should be 4. The 2x is going to go down a degree. And then the y, in this case it's negative 3, is going to appear. It's going to come up a degree. The next one is 6. The 2x goes down a degree. The negative 3 goes up a degree. 1, 4, 6, 4. Okay, 2x goes down a degree. Negative 3 goes up a degree. And then we end with a 1. The 2x goes down a degree, so it's gone. The negative 3 goes up a degree, so now it's to the fourth. And I'm going to very carefully simplify this. Okay, 2x quantity to the fourth. 2 to the fourth is 16, so this is 16x to the fourth. Okay, 2 to the third is 8. 8 times 4 is 32. 32 times negative 3 is negative 96. X to the third. Okay, now let's go to the next one. Quantity 2x squared is 4x squared. 4 times 9 is 36. 36 times 6 is positive 216 x squared. See, negative 3 to the third, negative 27 times 2, negative 54 times 4, negative 216 x. And then the last term, I just have negative 3 to the fourth, which is positive 81. Okay, so this should be the correct expansion of 2x minus 3 to the fourth. And this is actually one where I wouldn't have wanted to multiply it out 4 times. Okay, now if this were to the 10th or something, I certainly would not want to have to write out the Pascal's triangle. Do 11 rows of Pascal's triangle. And if I only wanted one of the terms, I wouldn't want to have to do that either. So there's actually a pattern or a formula to get the coefficient. So I'm going to look back up to here. Okay, so if I wanted to figure out the 1 using a formula, it actually matches up to 5 choose 0, which is also the degree of each of the exponents on that particular one. It would be x to the fifth, y to the 0. For the next one, 5 choose 1. This would be 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5 would be a way to calculate each of these coefficients without having to expand Pascal's triangle out forever. Okay, so that's the binomial theorem. Okay, binomial theorem says the coefficient of x to the n minus r y to the r is n choose r. This is just giving the formula. And another way of writing n choose r is writing it like this with these big parentheses. We pretty much never write it like that. but that's how the formula is expressed, so we're going to go with it. Okay, now let's look at the n and the r. Okay, the n is the degree of the binomial. Okay, so if I, for this one, the degree would be 10 because I'm raising it to the 10th power. Okay, now r is, you have to be careful of r a little bit. Okay, r is the degree on the second term, okay, but it starts out at 0. So r is actually going to be the term number minus 1, and that's because on the first term, r has a degree of 0, on the second term, r has a degree of 1, and so on. Okay, but let's just try it. Okay, so I only want the 8th term of x plus y to the 10th, so I don't have to do the full expansion. I just want to figure out what the 8th term is in that expansion. Okay, so let me look at the formula. I want to do n choose r. What is n? In this case, n is 10 because x plus y to the 10th power. Okay, what's r? R is I want the 8th term, but I subtract 1. And that gives me the degree of the y. Okay, now this number, remember, this is telling me the degree of the y. So I'm going to fill that in first. So this is x to the something, y to the something. The y is to the 7th. I want to know what the degree on the x is. Okay, these two have to add up to 10. So this must be 3. Okay, or according to this formula, it's n minus r. So 10 minus 7 would give me 3 there. Okay, I'm going to put 10 choose 7 in my calculator. Okay, and I find out it's 120 x to the 3rd, y to the 7th. So that's the 8th term in the expansion. It's not the entire expansion, although I certainly could use that for each of the terms if I wanted to. Okay, let's do the same thing for, or similar for b. I'm going to find the 3rd term of a plus 2b raised to the 8th. Okay, now let me think about the coefficient. N is 8, and I got that from here. What am I choosing? Since I want the 3rd term, r is going to be 3 minus 1. And remember, that's the degree on the 2nd term in the binomial. Okay, so I'm going to skip the a for a second. That's telling me what the degree on the 2b is. Okay, now this degree plus this degree must equal 8. So it must be a to the 6th. Okay, or I could do 8n minus r gives me 6. Okay, let me put 8 choose 2 in my calculator. I get 28, and then I'm going to simplify this a little bit because that's a to the 6th, and if I do 2b to the 2nd, I get 4b to the 2nd. Okay, so 28 times 4 is 112, a to the 6th, b to the 2nd. So that would be the 3rd term of the expansion. I don't know what the other terms are, but that's what the 3rd term is. Okay, we're going to do one more with a negative, just to make sure you're careful with your negatives. Okay, so let's see. In this case, n is 10. Okay, let's see. Because I want the 4th term, 4 minus 1 is 3. So r is going to be 3. Okay, now I want to do 3a to the something and negative 2b to the something. Because r is 3, this is negative 2b to the 3rd. 3 plus something to get 10, that must be a 7. Or I could say 10 minus 3 is 7. Okay, I'm going to use my calculator to evaluate this one. Okay, 10 choose 3 is 120. Now 3 to the 7th, I'm putting in my calculator. 2187, a to the 7th, and negative 2b to the 3rd. Negative 2 to the 3rd is negative 8. B to the 3rd. Let me multiply all those coefficients together and carefully write it down. 5, 2, 0, a to the 7th, b to the 3rd, and that would be the fourth term and the expansion, although the expansion would be much longer.